welcome back, I think. Yeah.
Well, we didn't just start, so welcome, unless they started with this module.
Well, but they don't. The modules are broken up. It could have been 3 days since the last time.
But still, welcome back.
Yeah, indeed.
So,
either way.
Or welcome, whichever the case. I am Thomas Willingham.
Hopefully not welcome, because if they're watching Module 5 first, then go back to the beginning.
Dude, we don't judge. People can watch in whatever order they so desire.
It's true.
Maybe that's not the best method, but people can do.
Judge.
Yeah, we don't judge much, and if I do, I'm not going to tell you.
Fair enough.
Yeah, actually, I'm totally going to tell you if I judge. I am Thomas Willingham.
I'm Christopher Chapman.
And we are here to talk about Windows Server Administration Fundamentals.
We are. That's good. I love the Vanna White.
I practice. When we're not on camera, I practice. Module 5, Essential Services. So we've been talking about Windows Server. In this module, we'll talk about the roles and services needed for running the server. So let's take a look at our objectives here. Looking at objects and introducing groups, introducing domains, trees, and forests, introducing organizational units, introducing directory services with Active Directory, and we'll talk about group policy. So the first thing, name resolution. Typically, as we deal with computers, we deal with www.microsoft.com. We deal with Win Server 12-15 or whatever. We deal with names. That's not how computers talk to each other typically. Typically, they talk to each other through numbers, using numbers of some kind. In this case, the numbers are IP addresses and MAC addresses.
Which you can learn about.
Networking Fundamentals.
There we go.
Good plug.
Awesome.
Good plug. That's a great course. Great course. Who taught that course?
I vaguely remember we did.
We did, which is why it's full of awesome.
That's true.
It is full of awesome. Okay, so name resolution. What you get with name resolution is it associates a logical address or a name with an IP address. Mm-hmm. So www.microsoft.com is associated to this IP address. Using surfing the web, it would be really difficult to remember IP addresses. That's not how our brains work. Sometimes we have a hard time remembering a phone number.
But you can always look up a contact in your phone by name.
Exactly. That's how we tend to work and associate is by name. The name resolution system enables you to use the name, and in the back, translation happens. This translation doesn't happen automatically. You need to set up the service for this to happen on your network. This service, a couple different types. One is for IP, domain name services. Again, learn more about this in Networking Fundamental. There's also WINS, Windows Internet Naming Service.
I think that's right.
For naming NetBIOS, for doing IP to NetBIOS systems. Oh, demo. We're at a demo already, and we need to demo. Yeah, we're going to demo hosts files. Host files are the file used initially to statically associate this computer name to this computer address. Take it away, Christopher, and show us what a host file looks like.
So we'll give a little bit of background. He'd mentioned DNS, he'd mentioned WINS. There's also a local method on every computer on a network that you can manually configure to map names to IP addresses. Now, I'm actually going to bring this up because you can play some fun tricks on people. All right, so let's get this open. We're going to browse to a rather lengthy and rather odd path to get to this file. Windows System 32 drivers, etc. is the path we're going to. Not sure why that's the path. One of these days, that's one of those obscure pieces of knowledge that perhaps I'll find out. We're going to open this file in Notepad.
And really quick, so host file is for DNS. There's also elem host file for WINS, which we'll talk about later.
It's true. I'm going to simply put in an IP address and a server name. Now, the server doesn't really exist, but I'm going to save it.
So you could use this for, say, testing purposes.
Yep.
You're doing some web development on your local machine. You want to just see how all that looks. You could use your host file to perform redirection back to your own machine.
I could also use it for testing purposes. I guess I'm looking at, say there's a production web server that I'm working on, or a production website that I'm working on. I want to use the URL for that site, but I don't want to go to the public site. I want to go to my internal test version. I can come in here and put the site in there with the IP address of my test server, use the same URL, and see the live version, the test version of the site. So I'm now going to ping server 45, the one I just put into this file. Notice it's going to fail because the server doesn't exist, but it is pinging 10.0.0.240 because that's the address I put in the file. And if I change this, save it, come back here, changes to 245. It's reading this file first before it ever goes to DNS. One nice thing about this is with DNS, things get cached. If I ping something with DNS and it gives me a result, and then I change the DNS end of things, it's going to try the cache version first, which means it may not find the resource it's looking for because the IP has changed. Here, it's instant. It's reading this file every time. So that's all. That's the host file.
Pretty straightforward.
Well, and again, I'd mentioned you can play some tricks on people. So if you can figure out how to map other IP addresses to known URLs,
Some fun could be had.
yeah, not that I'm saying you should,
Don't advocate,
but that it's
just
possible.
saying it's possible.
Yeah, it's gonna be done.
So if we kind of look at the evolution of networking, initially things used to be a lot more manually oriented. You had to manually input things. So host files used to be how IP addresses were resolved. Then DNS came.
Luckily, pretty quickly. There was not a big gap necessarily.
No,
I think people realized what a nightmare host files would be for management, and we're like, let's find a better way.
Well, host files were actually seen as like a LAN solution, and DNS was seen as more of a WAN-oriented solution. And then we got into benefits like dynamic DNS that enabled systems to, as they booted up, to dynamically input their address to DNS. So on the kind of continuum here, again, starting things were very manual, making entries, and then as we get into the future is a lot more, things are a lot more automatic. Things happen in the background for you.
Yep.
So DNS, we've been talking about the host file, which is how you would do this manually. Domain name system is the overarching system of how these names are resolved. DNS is short for Domain Name System. Again, fun to have at parties. It's a hierarchical client-server-based distribution database management system used to translate. I love the word hierarchical. It's a great word. Used to translate a name, a computer name, to an IP address. So that www.microsoft.com into a specific IP address. The top of the tree, oddly enough, is known as the root, which is the bottom of the tree. But that's not how it works. The top of the tree is known as the root. Let's not get confused here. Yeah. And below the root domain, you'll find top-level domains, such as the typical ones we're familiar with, com, edu, org, net, and then also some country codes, UK, CA, US.
So to clarify, right now on this slide, as we talk about DNS, the best example of DNS is the public internet. So that's what this slide represents. We're talking about Microsoft.com and other public URLs and IP addresses being mapped to each other. DNS is still used internally in most networks, almost all networks these days, and should be for larger networks. But the best example we give is a public one because those URLs are more recognizable, and it's a slightly more detailed process that it goes through. So that's what the graphic's all about on that slide.
Well, and the nice thing about DNS, public DNS, is whether you're on a home network or a work network, public DNS is still available.
Yep.
If you're on a home network, a work DNS may or may not be available.
Well, and I'd say maybe.
That's what I mean, may or may not be available. DNS zone types. So when you define DNS zones, you create the zone as either a forward lookup zone or a reverse lookup zone.
Now this, contrary to the last slide, we've moved solidly internal. If you're managing a DNS server for your network, this is where you have to worry about these things.
So the forward lookup zone, and then it gives some examples, technetmicrosoft.com or microsoft.com, has the majority of the resource records, including A's and C names.
And again, we talk about those in networking.
Yeah. Oh, networking fundamentals.
Yep.
Whereas the reverse lookup zone has PTR records. So the records associated are a little bit different.
Yep.
And then a demo for DNS. Let's take a look at some DNS goodness.
Okay. So we're right back here on my server desktop. And we're going to open up DNS real quick. Here it is right here in the Start menu. After I install it, it puts that icon there for me automatically. And here's the DNS server. We don't have any forward lookup zones. We don't have any reverse lookup zones. This server is just a bare, clean DNS server, not affiliated with a domain, nothing. So I can create a forward lookup zone. And I can call it whatever I want. I can make it a primary zone. Zone name, let's call this Christopher.test. The zone name specifies a portion of the DNS namespace for which this server is authoritative. And they give some examples, Microsoft.com, newzone.microsoft.com. Christopher.test is what we're going to create. Now, because this is a primary lookup zone, or a forward lookup zone on a primary DNS server that's not Active Directory integrated, which we don't really go into much in this course or in the MTA courses, it's going to create a file. And that file is where these records are kept. And this is the name of that file, Christopher.test.dns. And they give you the link to where that file is kept. Because again, we're not keeping this in Active Directory. If you're doing this in an AAD environment and you're building a DNS server for your Active Directory environment, odds are you're doing Active Directory integrated. There's no file. Dynamic updates we're not going to worry about because again, this is not Active Directory integrated. We may not have trusted clients. We may not know what's connecting to this server. So I've created it, and that's all it takes. I mean, at this point, I've created a lookup zone. Christopher.test. I can give it a host. Now I'm going to leave this blank. Use this parent domain name if blank, just to test this. 192.168.7.3, just for fun. Done. Command prompt, ping. Oh, you know what? This is actually not going to work. And it's because I forgot something. This server does not use itself as a DNS lookup. So you can see another little piece of the demo. I'm going to go into the properties for my network adapter and into IP4. And right here, you see my preferred DNS server is 10.0.0.10. Now I'm going to put the IP of this server into DNS. I'm going to make it second for now, the alternate. Click OK and close. And try this again. Notice it now comes up with a record. It's not going to find it because it doesn't exist, but it found the record, it gave me an IP, and then it's just telling me it's unreachable because it can't get to it.
Just because the name is resolved, as you said, doesn't mean that the computer exists or is currently available.
Well, and here, to demonstrate that, because this is a zone, and I've given the zone an IP address, essentially what would be a domain in an Active Directory configuration will still respond to DNS requests as the domain with IP addresses. Let's create an actual computer that doesn't exist. Server.christopher.test 192.168.7.250. And I've added that record to my DNS zone. So I'm basically building a network that doesn't exist in DNS to be looked up. I can come right over here. I can add server.christopher.test, and there's my record.
Demonstrating name resolution.
Yep.
And if that computer existed, you would then have access to that computer.
Well, and to bring this all full circle to things we've talked about in some other courses, to things we've talked about in this course, I could bring up a computer, tell that computer to get an IP from DHCP. DHCP would assign this DNS server as the DNS server to use for lookups. I could then tell the zone to accept secure updates and let the client update the records in DNS, and everything I just did by hand would be automatic.
And again, back to our continuum, things were a lot more manual intervention, and now with the secure updates, the dynamic updating system, a lot of that happens on the back end, behind the scenes. As systems boot up, they'll take care of it themselves.
Yep.
Wow, I got a lot of hand motion going on.
That happens.
Got to keep my hands limber because I have clients and servers to talk about at a later time.
I remember that.
Yep. Okay, so that was DNS. Thank you, sir. DNS round robin. So nowadays, you hear terms like load balancing, clustering. Before systems had the ability to load balance themselves, where you could, as you brought up the operating systems, you created or installed a service specific for load balancing or specific for clustering. Prior to that fanciness, there was a implementation of DNS round robin, which kind of facilitated load balancing or a clustering of type. And what this enabled is you in DNS would set up a series of separate machines that all responded to the same IP address or the same name. So you have separate physical servers that would all respond to www.microsoft.com. So effectively, through DNS, you could create a load balance, you could create a cluster of sorts. DNS queries and transfers, transfers between primary and secondary zones. This occurs over TCP UDP port 53. So if you have a firewall between servers, you need to ensure that you open port 53 for this DNS query and transfer implementation to occur.
Well, and something we didn't talk about in this primary and secondary, the slide kind of just jumps out at you. DNS can be configured in a way, so I created a primary zone on this server in my demo. DNS can be configured in a way that you've got one server that's authoritative for your zone or your name, and then you have secondary servers that also service requests, but you don't want to have to make DNS updates to all of those servers when something changes. So you make a change on the primary, that change is propagated out to the secondaries through this zone transfer process. So that's what that's all about.
So we've talked about DNS. We've talked about the manual part of DNS, host files. We've talked about DNS servers, dynamic updates. Now we'll talk about WINS, Windows Internet Service. Windows Internet Service, this was initially created because Windows' initial implementation was NetBIOS to enable Windows to intercommunicate with other systems on the network. They use NetBEUI NetBIOS. NetBIOS is non-routable, so it won't route across networks. And WINS was a system that was used to enable this name to address translation. So it's a legacy naming service. Contains a data just similar to DNS. It translates an IP address to a NetBIOS name. WINS, some issues with WINS is it doesn't have a hierarchy system like DNS. It's not routable. Well, I take that back. It can be routable. The protocol itself isn't routable, but there are ways to enable routing of the protocol, but it's not within the protocol itself. So it doesn't enable, or it doesn't allow dynamic updates, so you can't do dynamic updating. So for each entry, you have to add a static entry for your name resolution system. So again, to kind of reiterate, WINS was the initial system that Windows networking used to enable name resolution to IP addresses. DHCP, and a lot of this whole module, we're covering in a module what we covered in a day in networking fundamentals. So if this topic interests you and you'd like to learn more, networking fundamentals is definitely the place to go.
And what we cover in multiple days in the MCSA track, the 410, 411, 412. We're attempting to scratch the surface of an ocean of information right now.
Correct. Yeah, that's the one thing that's really kind of interesting about this course is, as Christopher mentioned, it's an ocean of information. We're just trying to at a very high level, give you some information about how this stuff works.
Hopefully just enough information to make you want to learn more, take more courses, take some classes, take some certification exams, the whole fun, then start a career, why not?
Could happen.
Yeah.
Or they don't have to start a career, they can just take the courses and gain the information for fun.
Learn how to mess with their friends.
True.
Yeah.
So we've talked about DNS, so IP address to name resolution. We've talked about WINS. We've talked about host files. DHCP. So in an IP environment, a TCP/IP environment, the systems, all devices on the network, to enable communication need an IP address. Initially, all those IP addresses were statically configured on each system. Down the road, DHCP, Dynamic Host Configuration Protocol, was created that enabled, as systems booted up and accessed the network, to automatically get an IP address and associated information. So if you look at the fancy graphic here, you'll see the client computer and DHCP computer. As the client computer boots up, it sends out a message that's a DHCP discover. So, hey, I need an address. A server responds back, and if we step back for a minute, a client requests services, a server provides services. So a server basically states, hey, I have DHCP addresses that I can provide. So the system, the client request does a DHCP request, and the DHCP server does an acknowledge and sends the IP address and information to the client. So DHCP IP address, a DNS gate, DNS information, a gateway, so whichever information is associated through DHCP. So now we have a demo of DHCP to learn more and to show, to illustrate how DHCP works.
Okay.
Christopher.
My turn. So I'm gonna do two things. I'm gonna add a little bit of value here because I'm not sure we've done this yet. I'm actually gonna install it because I'm not sure we've shown an install yet of one of these features.
Oh.
So I'm on Server Manager, which you hopefully have seen in previous courses at this point. I'm not sure. I think we covered them at some point.
Okay, quick aside here. Although this course is based in 2008, this is the 2012
It is.
UI,
Yep.
which I helped develop a portion of this
Nice.
for remote desktop services. Very exciting. It's very cool. But the functionality and process is the same between 08 and 2012, although the UI might be a bit different.
Okay. So we're here, we're going to add roles and features, and this is not a critical process for this exam or this course, so I'm just going to kind of breeze through it. But you get to see it, and you can watch this video over and over again if you want to see how it actually works. DHCP, yes, done, and install. This should take just a couple of seconds, and we'll be able to look at DHCP. I could close this, just as one of the fun features of the new server operating systems. You can start your role and feature installations, carry on about your business. We're going to wait for it to finish because, well, it's what we're working on right now. I am going to open administrative tools while we wait. Oh, I guess it's right here. So DHCP gets added. It is done installing. Let's close Server Manager. Back to our Start menu, and DHCP is here. So we've got this domain, Christopher.working, that I've created, and DHCP. Now I need to tell this server what IPs to hand out to clients that want IPs. Right click. I'm going to configure it before I turn it on. You'll notice it's red and looks like it's not doing anything. And beautifully in the console it tells you why. Before a DHCP server can issue IPs, you must create a scope and authorize the DHCP server. A scope needs to be done, and to authorize, right click and authorize, which we're not there yet. So this being down, if I go up to the top, I can look at authorized servers. There aren't any. Close that. Step one, create a scope. New. This is pretty straightforward. Main office, just give it a name. You can give it any name you want. There's no restriction. Except you have to be able to type. Here you go. What IP do we want to start with?
Yeah, one. One's
what IP
good.
do we want to end with?
25. Smaller office. We only have 15 systems currently.
Could be.
We want to enable or allow 10 for growth.
It gives me a subnet mask. It automatically chooses the subnet mask based on the IP address I put in here. And that's fine for now. Exclusion. So we selected 1 through 25. Let's say our servers are 1 through 5. I can tell this server not to hand out those addresses. Now, whether or not you want to just not have them in your scope or have them in your scope but excluded is up to you. I prefer to include them but then exclude them, because I like knowing in a single place I can go to my DHCP server and I can look at all the IPs I'm using and what they're for. Oh, 1 through 20 are excluded. That means that's where my servers are. Set the duration. The default is 8 days. Little bonus knowledge for anybody who wants to know. A client will attempt to renew its DHCP lease after how long?
Isn't it 50%?
50%. So in this case, 4 days. It's going to try and just check in with DHCP, say, are you still there? Can I still use this address? Are we all good? Yes. Reset the counter to 8 days. Configure DHCP options. I'll say yes just so we can see this. Your router or your default gateway. Probably 1. So I'm going to use 1. That's why we excluded it, because we don't want to hand out that address and have a conflict with our gateway. DNS servers. Now it puts in here the servers I'm already using on this server. I don't want 10 to be handed out. I want 7 to be the only one handed out. And it's already there. I don't even need to go through the process of finding it and putting it in the box. Done. Wins, no wins, skip that. Activate this scope and finish.
And you would create wins more if you had legacy systems in your environment, older
You would.
Windows systems.
I'm going to verify something real quick before I...
If you mostly have newer systems in your environment, Wins becomes less functional in
That's
the
true.
environment.
So, and we won't get into the finer points of, there's an actual DNS mechanism built these days to accommodate the requests that Wins facilitates normally, or NetBIOS facilitates. There's a way to do single label names now in DNS to circumvent the need for NetBIOS if you have, say, legacy systems that have NetBIOS names or require NetBIOS for functionality. We're not going to get to that level of detail. It is not required. So I've created my scope. We're here. We're looking at it. There's a note here that's going to pertain because of how I've logged in to do this demo. I mentioned earlier that the server must be authorized in Active Directory before it can assign IPs. This is a way to prevent what are called rogue DHCP servers on your network. Look that up if you get a second. It's tons of fun to troubleshoot when it finally happens.
It's horrid.
Horrific.
Horrid. How many emails have you received? Would the person who created a rogue DHCP server please take it down? And normally when somebody creates a rogue, I don't know why this happens, but normally when people create and authorize a rogue DHCP server, they go on vacation. Hey, I'm going to authorize this. I'm out. I don't know why.
Sounds like fun to troubleshoot. I haven't had that problem because I usually put them in and then forget to turn something else off or something. Something usually my fault is what happens. So we're here. We've created the scope. There is a note. It has to be authorized, but they give you instructions to authorize this DHCP server. Navigate to the server node, and on the action menu, click authorize. Okay, let's go to the server node. Action menu. There is no authorize.
Huh, but why, pray tell?
Very confusing. I would sit here for days trying to figure that out. You will need to log in as a domain user with requisite privileges to authorize the server. We are doing this against Active Directory. I'm actually logged into the server as a local administrator, not as an Active Directory account.
So you do not have requisite privileges.
So I cannot authorize this DHCP server. But that would be your last step, and then you'd be up and running serving DHCP addresses.
Sweet, sweet. So we've talked about DNS, we've talked about Wins, we've talked about DHCP. Now let's talk about directory services. So directory services store, organizes, and provides access to information about the network, about objects on the network.
What's the classic analogy?
Oh, the phone book.
Indeed.
It is similar to the phone book. The directory structure is used for looking things up, looking objects up. Printers, computers, users, servers, devices on the network that get stored into the directory structure. The objects have associated attributes with them. User ID might have name, first name, last name, telephone number, office, email address. So these are all things that would be associated to a user object. One popular directory service is Microsoft's Active Directory. So Active Directory, technology created by Microsoft, provides a variety of network services, including LDAP, Kerberos-based and single sign-on authentication, so secure authentication, LDAP, lightweight directory access protocol, DNS-based naming and other network information. So as Christopher mentioned in the DNS demo, the ability to add DNS information to Active Directory. And it is a central location or repository, storage location, for network administration and delegation of authority. Active Directory requires DNS. So delegation of authority kind of goes into this next slide here. Active Directory has a logical structure to it. You can associate an area for your computers. You can associate an area for your users. Then you can delegate those areas. So instead of just having a huge main area for your users, you might even have it broken out even further. These are your accounting users. These are your finance users. These are your marketing users. Then you could say user Joe is the administrator of the accounting people. User Mary, although it's probably not just a user, they're an administrator. Administrator Mary has access to manage the marketing people. Another user has access to manage the computer area. So by delegating this, you don't have a single person responsible for the whole structure. You have areas of responsibility. So the logical structure for Active Directory includes a forest, which is the overall structure, the tree, and the domain. To allow users in one domain access to resources in another, Active Directory uses trust relationships.
Which again, we're not going to get into great detail on. It's a whole other conversation for days. Days of classes.
Yes. Yeah.
So for now, just know that a forest can have multiple trees. Those trees contain domains. They're defined as trees by the domain at the top called the root domain, as we talked about before. And all those domains communicate with each other through trusts.
So the physical structure. Active Directory is a logical structure of the system that relates to a physical structure. Sites and domain controllers are part of that physical structure. A site is a logical area of the network that all has high-speed access to each other. So anywhere within a high-speed access of the network, a building, a campus, whatever that all has high-speed network, that would be a site.
I would almost change that and say a physical. Because you said a logical
Oh, you're right.
grouping.
You're right.
A physical grouping. Now, it may be a building, like you said, a campus. It may be a city. It may be multiple states at this point, given the speed of interconnectivity.
Correct.
And what's available. But, yeah, that's just want to throw the word physical in there.
Correct. Yes. And then domain controllers. Domain controllers are the physical machines that store this information, that store this Active Directory information on them. So systems on a network, on a Microsoft network, can be a domain controller, which means they're basically a management server. They contain Active Directory structure or management information about the network on it. There's also member servers. Member servers are servers that can still hold services or still run services, DNS, DHCP, file and print, web, but don't necessarily have an Active Directory management component to them.
They're members of the domain. They're not managers of the domain.
Correct. And servers can be promoted to be domain controllers or demoted to be domain controllers.
To be member servers.
Or to be member servers, correct. Global catalog. So a Active Directory domain controller only has information for the domain and does not store information about objects in other domains. So when we talked about trust relationships, you may still need a method to find out information about other objects in other domains. A global catalog represents the information of every object in the tree and forest.
And I will say, as a caveat to that, it's a subset of the attributes of those objects.
Not the entire tree.
Yeah, a global catalog is not compiling one massive copy of all of your domain information. It's keeping a subset. It's kind of a lightweight reference point to objects in other domains in a forest.
By default, a global catalog is created on the first domain controller.
Yep.
That's created on the service.
Can I create them after that?
Yes, it can be created on any domain controller, but by default is on the first, number one.
That's good.
FSMO roles, flexible single master operation roles. So Active Directory, so domain controllers also have additional functionality. Active Directory uses multi-master replication, so there doesn't have to be one single point of failure for it. It enables replication of that database.
What that means is there's no boss.
There's no boss, correct. So there's no master domain controller, as it were. There is a primary domain controller, but this can replicate information to those secondary domain controllers.
And the primary domain controller is not what it used to be. So in NT4, there was a primary domain controller that worked very much like a primary DNS zone. You would have a domain controller that you made all your changes on, and those changes were replicated out to other domain controllers that the network could then consume, read information about, find locations of things. With 2000 and later, that went away. But what happens is there are things that primary domain controller did that you still need it to do specifically. There needs to be one specific point of time in a domain.
Time stamping.
Yep. There needs to be one specific point of password resets in a domain. So if you have 3 users on 3 different servers all reset the password, or one user, well, I guess the realistic example would be multiple people changing passwords on the same account nearly simultaneously in different locations, there becomes an issue of who wins.
Correct.
And what happens is all those requests go to a server that acts as what used to be a primary domain controller, and that server determines the winner. So
it rolls dice.
That's it's which password are you gonna have to use? Pick one. So yeah, Windows 2000 made things easier and slightly more complicated. Easier in that there's no more worrying about this hierarchy of domain controllers. Everybody's a domain controller that you select to be, and all those domain controllers serve that purpose. But there are things that are still single server specific.
So our FSMO roles, PDC emulator that enables backward compatibility, password changes, and is the master time server, as opposed to the master key server, who's the person who holds the keys at a party when people get drunk and then won't give them back.
Makes sense. It's fun, and I don't even want to go into that. I start thinking about keys and Kerberos and
We'll actually talk about keys and Kerberos a little bit later.
Hopefully.
Infrastructure master. So this syncs cross-domain group membership changes.
Because there are groups, I think that we'll learn about at some point, that can be used across domain boundaries.
Yes. The RID master allocates pools of unique identity.
Should be identifiers.
Identifiers, yeah, as identifies to domain controllers for use when creating objects.
Yeah, every object in a domain gets an ID. We usually don't see them. They're hidden.
It's behind the scenes.
It
a
is
GUID.
way behind the scenes. Yes, it is indeed a GUID.
It's the GUID.
And across a domain, you've got to have unique IDs for everything. So there's got to be one domain controller that's in charge of that list of what those IDs are, what's been used and what hasn't.
The domain naming master controls the addition and removal of domains from the forest. Mm-hmm. And then the schema master controls and handles updates and modifications to the AD schema. So really quick, the hard and fast is, I've talked about the fact that objects have associated attributes. A user has a username, first name, last name, username, office, telephone number. So these attributes make up an object. When you install additional role services that are Active Directory aware, they may expand the schema of Active Directory. Let's take Exchange, for example. You install Exchange in Active Directory, and now that might populate additional fields, for example, an email address field that didn't previously exist. So now we've actually changed the object or the attributes associated with an object and expanded the range of attributes.
Yeah, one of the most powerful and most dangerous things about Active Directory is it can be modified. the definition of Active Directory itself can be modified. And we do that through the schema.
And that's one reason that environments are so unique. Different environments have different applications installed, and they may have multiple applications that have expanded the schema of Active Directory to really change and make it unique for that environment. So functional levels. Domain controllers can have functional levels. Windows 2000, Server 2003, Server 2008, and these functional levels have different capabilities. It can be dangerous when you start mixing and matching domain controller levels. Actually, that's not quite true. It's not dangerous. It can just create sporadic behavior.
Well,
so you want to ensure a consistency of functional levels between your domain.
Exactly, and what the place where that may be an issue is when you're upgrading. I've got 500 2008 R2 servers right now in place. Some of them are domain controllers, 50 of them are domain controllers. I need to upgrade to 2012 or 2012 R2. I can bring in 2012 R2 domain controllers right now, but those domain controllers can do things that those 2008 R2 domain controllers can't. I can't use that functionality until all of the servers involved can recognize and consume that functionality.
Correct.
So I tell those 2008 R2 servers or the 2012 R2 servers to run at a lower functional level so that they know how to communicate directly with those 2008 R2 servers without any mismatched features or miscommunication.
Delegation of control. So we've talked a bit about the hierarchical nature of Active Directory and the ability to delegate control of certain areas or delegate administration of certain areas within Active Directory to appropriate users. Active Directory objects, we've talked about this a little bit. This is a distinct set of attributes associated with an object, a user object, a printer object, a computer object, represents a network resource of some kind. Mentions some common objects within Active Directory. Attributes have values that define the specific object. So these attributes define this object. And again, that's referred to as the schema. And as you install directory-aware applications, the schema may be updated or expanded. Active Directory's objects are assigned unique identifiers called GUIDs, globally unique identifiers.
Handed out by which server?
Domain controller.
Which domain controller?
Primary. Oh, the FSMO. So that's a FSMO role, and that is... Oh, I'm blanking out now.
The RID master.
Oh, there we go. The RID master. The RID master. Now, the GUID brings up an interesting point. I have user Fred, and I associate certain permissions and attributes with Fred, and I fill that out. For some reason, I delete Fred. Then I decide I feel bad, I recreate Fred, and now Fred no longer has the permissions associated to that account. The reason being is permissions and information of that nature are associated to the GUID. Every new object you create has a unique GUID. So even though the names of these two objects are the same, so here's Fred, I deleted this one, I recreated a Fred, it has a new GUID, so it's, even though it's named the same, it's actually a different object, if that makes sense. User accounts. These enable a user to log in to a computer in a domain. It proves the identity. So typically there's a username and password referred to as a set of credentials. This can also be used for auditing purposes. So user Jones logged into system at so-and-so time. You may do pass or fail audit. So user password success, user password fail. And then there's there's two types of user accounts, a local user account and a domain user account. A local user account is only good on the local system. So we've talked a little bit about peer-to-peer networking. On a peer-to-peer networking, every system needs a local account that you're going to work on. Domain user accounts are a single account that the user can use within any system on the domain. So we've talked about user accounts. The next thing to talk about are permissions. These are a specific set or type of access granted to an object. The most common objects assigned permissions are NTFS files, so files, folders, printers, and Active Directory objects. And then which user can define or manipulate an object or can access an object are recorded in what's referred to as an ACL or access control list. The ACL lists all users and groups that have permissions for that object. So we've talked about user accounts. There's also computer accounts. Computer accounts define computers that authenticate and access the network. Each computer that you want to grant access to must have a unique computer account. They can also be used for auditing purposes, specifying what system was used and when something was accessed. Now we've talked about permissions. One way to associate a user permissions is giving that user permission directly. But when you start to have 10, 20, 100, 1,000 users that need permissions, groups become a easier, more streamlined method for associating these permissions. So instead of getting a new accounting person, whoever that may be, so you have new accounting user, and you need to ensure that they have permissions to everything that the accounting people use, you create a group. Now whenever somebody leaves or comes in, if somebody leaves, you just remove them from the group and delete their account. When somebody comes in, you just add them to the group, and any permissions associated to this group will be associated to that user. There are two types of groups in Active Directory, a security group and a distribution group. Distribution group is typically used for email. Security group is not only does email alias type stuff, but will additionally enable permissions to be associated to that group. Using groups, there are multiple types of groups, and it mentions the mnemonic AGDLP. So the domain local groups and the other groups are accounts, global, domain local, and permissions. These are how you effectively figure out the permissions in your system.
How you apply them.
Exactly, how you apply them. If you're using universal groups, you can expand the mnemonic as AGUDLP. So built-in groups. By default, Windows has some built-in groups that users can be automatically entered into that will give them a certain level of permission. There are domain admin, domain users. These are obviously in a domain-oriented environment. Account operators, backup operators, authenticated users, and everyone. There's also a group that enables remote desktop users or remote usage. So if you want somebody to have associated permissions, you add them to this group, and then any permissions associated to this group will be given to that user. So we've talked about these different Active Directory objects. Now let's talk about the tools that can be used to manage these objects. The consoles include Active Directory users and computers, Active Directory domains and trust, sites and services, the administrative center, and the group policy management console. The group policy management console enables you to manage group policy, and then the Active Directory management consoles enable you to manage the different components of Active Directory. So, amazingly enough, we have a demo for Active Directory management tools.
Oh, do we?
We do.
Interesting. I suppose we can manage one of those. Let's jump right in. I'll have you walk me through the list. What's first?
First, Active Directory users and computers.
So we are going to go a little bit off the beaten path in that regard. So what I'm going to do, I'm going to make sure I'm on the right server, which I'm not. I'm not even on the right server here. Let's go here. Oh, close my Facebook because nobody wants to see that. Close DNS. And we're going to go to administrative tools. Now, the reason we're going to go to administrative tools is to see a list of some of the tools we're about to look at. Active Directory got a little bit more complicated in Server 2012. In 2008, this is what you see, this is what you work in, this is what you use. We're talking about users. It's relatively straightforward. You've got a domain. That domain has organizational units. Within those organizational units, you've got, well, all sorts of things that you can put in here. Users, groups, all the things we've talked about. And I could create dozens and dozens and dozens of them. In fact, this is my best example. Let's look at my SharePoint service accounts organizational unit. This tool can be used to modify these accounts. You double click or right click and go to properties. Here are all of your attributes and all of your properties you can change and manage.
So those attributes combined are what make up that object.
Yep.
And as different Active Directory aware applications or role services are installed, you may get additional tabs in that object.
Yep. So that's all for users and computers. That's all we're going to look at. Although there is a computers container that shows all sorts of computers. A lot of these are disabled because I don't use them anymore. I do a lot of server experimenting. So that's what those are all there for. Now I'm going to close this, and because we're in 2012, I'm going to open up the new tool. Now again, this is not something you'll see on the MTA exam for this course because that's all based on 2008, 2008 R2, not 2012. So as of right now, you will not see the ADAC. But I'm going to show it to you anyways because I like adding value.
Well, according to Barney from How I Met Your Mother, new is always better.
Fair enough. What's the next tool on the list while this opens?
Domains and trusts.
Okay, we'll come to that in just a minute. So here we go. We've got, now this is a little different because it doesn't show you a whole lot right off the bat. Right here I've got my domain, but I only have a couple of containers. And that's because I've only looked at a couple of containers. Essentially what this is a frequently used list. So here I can go to the same place I was before, expand that, expand this, expand this. Well, let's just do that. Let's do SharePoint. Nope, that's not what I wanted. Go back. Here, here, and here. So I double click there and it gives me the objects in that organizational unit and it walks me through it up here, Chapman, Service Accounts, SharePoint.
And it's these areas that you can use, or these folders, this hierarchy that you can use to start delegating administration.
Absolutely, absolutely.
So if you had a SharePoint administrator, you could give them administrator functionality to this folder within your Active Directory structure.
Yep. So here we've got an account. We go to properties. It's just a different view. Instead of having that small multi-tab screen, we now have this. And it's all in one place. It's all on one screen. Now we do have links over here, but those links just bring us to different parts of this page. You'll notice extensions, profile, password settings. So it's all one page. All the same attributes up here, first name, last name, full name, UPN name. You can see all my service account information. Sneaky. Password options, it's all here. So this is just the new tool. Close that. Again, it's just a glimpse. It's not part of the exam, so we don't want to spend a lot of time. Domains and trusts. Let's open this. And I only have one domain. Right-click and properties. A lot of this is going to be right-click and properties. Trusts, this is where you manage trusts to other domains. If I had other domains in this forest, you would see that here. They're automatic.
And what that enables is users in one domain to access objects in another domain.
Yep.
It is possible that you could have multiple domains in your environment that you don't want the users to be able to access information back and forth from. Maybe you work in a financial institution, you have an auditing side of the house, and you have a other side of the house, and you don't want those two to play, and you want them to logically be separate entities. You could create separate domains for them. That's one way to perform that action.
Yep, and just not have a trust. So that's pretty much it to domains and trusts. There's not a whole lot to it. You can create new ones with other domains if you can get to them. And that's what this is. Yeah.
Sites and services.
So here's a fun trick though. Every one of these consoles, when you right click on the domain name, you're going to get different options here. So notice there's a manage under domains and trusts. Takes me to ADUC, users and computers. Also notice raise domain functional level. This is where I can change this. So we're going to close domains and trusts, and what's next?
Sites and services.
Sites and services is probably next. This one is a little bit more involved. I only have one site.
And again, a site is a physical area of high-speed connectivity.
Yep, exactly. I have one site. It's got servers in it. The end. I only have 3 domain controllers. In fact, one of these is no longer a domain controller. I should get rid of it. Here are my servers, and that's why server DC2 doesn't have a dropdown, because it doesn't exist anymore. And here is a site connection, automatically generated from server vert, which is down here, to server right here. My 2 domain controllers are connected to each other through site links. Well, yeah, site links for now is what we'll call it. They're not site links because they're not inter-site, but that's not anything we need to go into the details on here either. So here's a site link. There's only one. I only have one site. I don't have multiple sites, so I don't have links connecting them all together. I'm trying to think of how to keep this as high level as I can, because it's tough not to go into lots of detail right here.
At this point, honestly, I think we say the end.
There was one other thing I wanted to show here. Oh, no, I'm going to get mired. Sites and services, where you define your sites and you define the connections between those sites. Each site, again, being a physical grouping of high-speed connected devices, objects, servers. Yes. The end.
Throw some group policy management my way.
Oh, wait, one more time.
Group policy management.
Okay, I'll leave this one. This one doesn't have any FSMO roles or no changes. Change forest, change domain controller. You're just retargeting the tool at that point. You're not managing anything. Group policy management. All right, so, this one's even harder. These demos get more difficult as we go.
Okay, so really quick, for those unfamiliar, group policies enable you to set
policies.
Policy, exactly. I was trying to think of like a word without using policy in there.
I would say they let you define and restrict functionality.
Functionality, characteristics and functionality across the network structure.
Exactly. So I have a couple things here. I have firewall policy that defines firewall rules for every device on my network, i.e. start menu taskbar policies. I can turn the start menu off. I can turn the taskbar off. I can lock the taskbar in place. I can change the appearance of notification icons, and I can define that for my entire domain.
So for a specific group on your network, you could lock down the start menu and only give those users access to these specific components in the network.
Yeah, pretty much. Again, this is, oh my goodness, I'm standing on the edge of a cliff looking at the Grand Canyon going, we should fill this with water. Let's fill all of it all the way up. We're not going to do that.
Instead of filling it with water, why don't we just point and say, there's some nice stuff over there, there's some nice stuff over there, which we've done.
That is a good way.
We've pointed out some nice stuff.
Yeah, the group policy management console, you'll get into here. I will go this far. Right-click, edit.
There we go.
I'm not clicking on it. I'm not doing it.
Click on it. Show a single group policy and what that.
We're going to be here forever.
No, we're not. No. So, yeah.
Now, here's the fun part. This is deceptively simple. Oh, there's a couple folders here for me to look at. That can't be that hard. It can't be that much for me to look at. What is all this fun stuff? I wonder what I can do with all this. Well, there's only a couple of options, so, it can't be that big a deal. Just wait. Like, it's thinking. It's thinking about all of the things that can be done right now with group policy. Let's expand some of this. Oh, now we start to see some power.
Right.
Account policies.
So let's look at like a password policy. What might a password policy look like?
And then within each of these, what will end up being hundreds of objects on the left-hand pane, you get potentially dozens of settings to modify, change, control. This one is not my password policy, but so that's why none of these are defined. I create separate policies for each thing I change, and this was my IE taskbar and start menu policy. So nothing here is defined.
So if this were associated to a user account, you could associate a password history. You could associate a minimum password length, a maximum password length.
There's a caveat to that, though. I can't associate password policies. Well, how do I word this? There was a time when you could only apply password policies to a domain, to an entire domain. And it was blanket, applied to that domain, and done. You couldn't apply a password policy to a user. That did change recently. So you can now create individual password policies and then apply them to individual users or objects in the domain.
Wow, you went way further with that when I was speaking generally that you could associate.
Yeah, but you said to a user, and it'd be tricky. If someone comes in here and tries to create a policy for a level lower than the domain,
Correct.
It won't actually work. So that one's tricky. We don't want them to
No, that's fair. That's totally fair.
be misled. So yeah, that's all I'm going to show. I'm closing group policy management because even I'm just going to be like, let's play, let's do some stuff,
let's do some things and stuff.
Yeah.
Demo for Active Directory objects, showing user groups and organizational units.
Okay, so I'll open up ADUC one more time. We'll jump into where we already were. I'll go back to the service accounts OU that I was in. Now I'm actually doing this incorrectly. I'm doing something wrong here, and that is you don't use organizational units in Active Directory as a means of organization. I know they're called organizational units, but that's not what you use them for. You use them as a means of administration. In theory, all of my service accounts, all of these, and all of these, should all be in a single service accounts OU with policies applied to it that pertain to my service accounts. Password restrictions, password change policies, whatever the case may be. Having separate SCOM, SharePoint, and SQL organizational units is for my sake. It's just for me to keep track of which ones are which. Not a good administrative practice, but it's my home network, so I'm pretty sure having a domain with dozens of service accounts for the servers you're running at your house is not a great administrative practice. Of course, we're into life issues at that point. So these are users. I know they are service accounts in this case, but they are user accounts and user objects with all the properties associated with user objects. They're in organizational units that I have created inside of my domain. And there are computer objects as well. Again, you can see a number of these are disabled. I could, in theory, and why not, because I like adventure, delete. Contains other objects. Yes to all. Gone.
Well, and then let's take a look at some attributes associated to a computer.
Okay.
So we've seen some attributes associated to a user. Now, notice that we have here DNS name, DC type, site, and description. And again, these are the attributes that make up this object.
Well, and I'm going to show something. I'm going to bring up a domain controller. And you'll notice the pages are different. This one actually says DC type, workstation or server. It's not a domain controller. This is a domain controller.
And that shows...
This is a domain controller.
Yes.
So if it just says workstation or server, not a domain controller.
Workstation or member server, as it were.
Exactly. Site, because these are domain controllers, the site is defined, whereas with member servers or any other servers are not. So yeah, operating system keeps track. This one is 2012, so you see a different version. It's kind of nice. You see members of groups. This one's just computers. This one is domain controllers and cert publishers because I've got certification or certificate services installed on it. I've also got exchange information in my AD. So yeah, this is what a computer object looks like. So we won't again, I dip in the toe in the water, keep trying to jump in the pool. We're not going to jump in the pool.
So, and again, the most common 80 objects, users, groups, computers, and organizational units.
Yep, and you're probably going to deal mostly with users, groups, and OUs. Even computers are relatively self-managed until you start getting into means of cleaning up old, unused computer accounts.
Correct, correct. And then you can use tools like System Center or that have management capabilities to perform the functions to administrate your servers. Group policies.
So we saw the management tool.
We saw the management
We've
tool.
actually pretty much talked about them.
We have actually. So again, group policy enable you to manage the features and functionality of objects within your Active Directory structure.
And something we didn't talk about is that includes servers as well. And it in fact includes domain controllers. If you want to set, one of the great things you can set is logon policies. I can restrict who can log on to a domain controller using group policy.
Or no local logon.
And in fact, that's done by default.
Ta-da.
There is a default domain controllers policy that defines who can log on to a domain controller.
And then applying group policies. So group policies are applied within the Active Directory structure, and they can be applied at different levels. Typically, whatever you assign at a higher level flows down to the lower levels.
And I think what we're looking at right here is, yep, this is the actual order. I put that on the slide. So you can create group policies on a local machine. Those will exist and function until they're overridden by something at a site, domain, or OU level. And they are applied in that order. If you set the same policy in all 4 of those places, the OU is going to win.
So there's a demo for group policy.
We've seen it. So we're cutting out order here, I guess, a little bit.
Yeah,
I should have taken group policy off the management tools demo slide.
But we got into group policy, and group policies are kind of exciting. There's some cool stuff that can be done there, and we couldn't help ourselves.
They're amazing. Yeah, group policy is one of my favorite things. I've got some good group policy stories too.
There's neat stuff.
I had someone living with me years and years and years ago who at one point couldn't power down his own computer because I was learning group policies. Power button just didn't work. There was no shutdown option. I had nothing to do with it. Wasn't me.
Sometimes things happen.
It's weird.
I'm hurt.
Why?
You know why I'm hurt.
Oh, I know. I know what you're going to say. I just don't know if I share your sentiment.
It's the end of this module.
Awesome.
We have given you information about essential services.
We have. Are we at our little review slide?
We are at our
We
review
should put
slide.
that massive review slide on the screen so people can see it. Books, courses, exams. I mean, we're here to eventually get certified. There's a book for the MTA exam. You can get that. You can read through it. You can look at the materials. Take an instructor-led course. There are a number of options there. Prerequisites, post-requisites. I would say networking and security fundamentals, definitely things to have before you dive into the Windows Server fundamentals. So take those if you haven't. Run through the videos on MBA, grab the books, take the certs, start a career. Or again, don't.
And enjoy your education.
Yeah,
enjoy the knowledge. There's some neat stuff out there. There's a lot of great courses on MBA, and it's free.
It is. And there's more to this one, so come back for the next module.
We'll see you soon. I miss them already.